Hey everybody, here's a solution to problem 33 from Solving Quadratics Day 2. If you take a look, the problem asks you to write a quadratic function in the form ax squared plus bx plus c equals 0 with roots p and q. So I want to jump right in on this one. Okay, we take a look and you had to build with roots p and q. So what that means then, I can put a therefore, P and Q are the solutions to that equation. And therefore, I could almost work backwards then. I'm going to put in a bunch of lines in green you would never have to show me, but here's your theory. If that's the case, then at some point you would have had therefore, x is going to equal P or x is going to equal Q. And if we think about the factors those would have come from, we would have needed factors that equaled 0. So it's like I could go backwards and make those statements each equal to 0. If that's the case, then I know that x minus p times x minus q has to give me 0, as my product, the multiplication, has to give me 0. And if you take a look at that solution, I'm just going to shrink it down for a second, and you went backwards, you'd notice if we had the product equal to 0, then either one of those factors could equal 0, and therefore we could solve. So, because the question asks you to basically write it in standard form, write it as ax squared plus bx plus c, then that means I need to take those gold brackets and I need to expand it. I'll be honest with you, that's probably one of the more difficult things that you have to deal with, putting it in that proper form. So you relatively quickly should be comfortable to go through and expand all your brackets. But you'll notice it's a little tougher to collect like terms because you don't have a constant out in front of your of your x. You've got a q and you got a p. So it's going to look a little weird if I said I'm not common factoring. All I'm doing is collecting. But I'll notice I have no other squared terms, so I can't put those together. But if I did do this, the question says that I need to put that in the form ax squared plus bx plus c equals 0. So what that kind of does imply is that I'm adding my b value. If you look at my middle term, I'm adding my b value. So what I need to do then is add, and if I took my coefficient of my first x, negative q, and I then collected that with the coefficient of my second x, my negative p, that would give me the coefficient on my x term. And I get to that point. I just want to slide that across for a second and just make sure that you understand I didn't do anything weird there. Like at some point in your life when you learned how to collect like terms, there would have been a time where we said, okay, if you have 3 a's plus 5 a's, you just collect those and say you have 8 a's. But really what we're doing is we're saying you have 3 plus those 5 of a's. And so you basically just take your coefficients and collect. That's all we're really doing back over with the blue. We're taking our coefficients and we are collecting them. Now, there is nothing that says the order you have to put that in, so you could have a negative p minus q. It does not matter. There you go. If you take a look at my last blue line, that is my quadratic equation in the form ax squared plus bx plus c equals 0. You'll notice, if I just make a note, my a value is 1, my b value is negative q minus p, and my c value is pq. And there we go. Okay, I hope that helps you through your practice. Keep it going. Good luck.